This video covers section 3.2, graphing equations in two variables. Objective 2, graph a line using intercepts. We've seen how to plot points to obtain a graph, and another efficient way is to graph a line using intercepts. The intercepts are the points, if any, where a graph crosses or touches a coordinate axis. We have the x-axis and we have the y-axis. So a point at which the graph crosses or touches the x-axis is an x-intercept, and a point at which the graph crosses or touches the y-axis is a y-intercept. So for this graph, we see on the x-axis that the graph crosses at this point. That point has an x value of 3 and y value of 0. Remember, on the x-axis, that's where y is always 0. So we say that the x-intercept is 3, 0. We look where the graph crosses the y-axis, and we see that it crosses at the point 0, -2. The y-intercept is 0, -2. Pretty easy to see. The major takeaway from this is that the x-intercept must have y equal to 0. And the y-intercept must have x equal to 0. And that gives us our procedure for finding intercepts. To find an x-intercept, we know that it crosses the x-axis where y equals 0, and so we set y equal to 0. So for this graph, in order to find the x-intercept, we would set y equal to 0. In doing that, we get 2x minus 5 times 0 equals 20. Plugging in 0 are always the easiest ones, and so we get 0 for that, and that says that 2x is equal to 20. We divide both sides by 2, and we get x is equal to 10. Now we state that x-intercept as 10, 0. So we go over to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we put our point there. To find the y-intercept, we see that the y-intercepts, if any, we set x equal to 0. In doing that, we get 2 times 0 minus 5 times y equals 20. 2 times 0 is 0, so we have negative 5y is 20, or y is equal to negative 4. So our y-intercept is 0, negative 4. Now I always want to have a few more points on my graph, so I go back to plotting some points. The way we achieved this in objective 1 was we solved for y. If I solve for y here, I'm going to subtract 2x from both sides. Negative 2x and 20 are not like terms, so we can't add them. Then we get the y by itself by dividing by negative 5. And the equation is y equals 2/5 x minus 4. So remember, this gave us a nice way to plug them into our t-chart. With a denominator of 5, we want to use x equals only multiples of 5. With a 5 in the denominator, 2/5, you want everything you plug in to be a multiple of 5. So we've already got x equal to 0. We've got x equal to 10. Let's plug in 5, -5, and -10. 2/5 times 10 minus 4. 5 goes into 10 2 times. So -10. 5 goes into -10 -2 times, and -2 times 2 is -4 minus 4 is -8. So at -10, it's at -8. Plugging in -5, we have 2/5 of -5 minus 4. 5 goes into -5 -1 time, and that's -2 minus 4 is -6. So we go over to -5 and go down 1, 2, 3, 4, 5, 6. And the last one, plugging in x equal to 5, we have 2/5 times 5 minus 4, and the 5s will cancel. That's 2 times 1 minus 4 is -2. So we go to 5 and -2. I see all my points lie on the same exact line, so I know for certain that I'm correct here. Connect my dots with a straight edge. And there's our line. So I urge you to press pause on your video and practice this problem in the same way that we did the last one. Set y equal to 0 to find the x-intercept. Set x equal to 0 to find the y-intercept. And then solve for y and plug in a couple of points. So now that you've had a chance to do that, I'll work this out for you. The x-intercept, we always set the other variable equal to 0. Setting y equal to 0 gives us 4x minus 3 times 0 equals 12. Cross that out, and we have 4x is equal to 12. Divide both sides by 4, and we get x equal to 3. My x-intercept is 3, 0. Finding the y-intercept, we would set the other variable equal to 0, setting x equal to 0. In doing that, we have 4 times 0 minus 3 times y equals 12. 4 times 0 is just 0, and we're left with -3y is 12. We solve that by dividing both sides by -3, and we get -4. So our y-intercept is 0, -4. So those are the intercepts. And now we'll find some more points on the graph by solving for y and plugging some x values in. Let's subtract 4x from both sides and get -3y equals -4x plus 12. Dividing both sides by -3, the -3's cancel out, and we have y equals -4 over -3, which is 4/3, and 12 over -3 is -4. I can see by this table, or by this equation now, that my table, my x values with a denominator of 3 use x equals multiples of 3. So we already have 3, so let's use 6 and 9. And let's use -3 and negative 6. So 4/3 times negative 6 over 1 minus 4. The 3 goes into 6 twice. That's 4 times negative 2 is negative 8 minus 4 is negative 12. Negative 6, negative 12. Plugging in negative 3, we have 4/3 times negative 3 over 1 minus 4. The 3's cancel, leaves us with negative 1 times 4 is negative 4 minus 4 is negative 8. Negative 3, negative 8. We've got 0 already. We've got 3, so let's plug in 6. 4/3 times 6 over 1. 3 goes into 3 once, into 6 twice. 2 times 4 is 8. Minus 4 is 4. So we have 6/4. And we can probably see the pattern of what's going on here. But let's plug it in one more time, and we'll talk about patterns in subsequent sections. So plugging in 9, 3 goes into 3 once, into 9 3 times. That gives us 12 minus 4, which is 8. So now we have 9/8. And all those points lie on the same line, so we connect our dots using a straight edge. And there's our line. So plotting using intercepts is an efficient technique, and the intercepts are very important points on the graph.